Patience. Patience. No. All right. What ones do you want to go over from Prop Set 31?
I would like to go over number 28.
28.
Does anyone have hand sanitizer?
I got it.
Okay, 28. We've got negative C, parenthesis, AC, minus a to the 0. If a equals negative 3 and c equals 4. Remember, before we do problems in this class, we always want to make our lives easier because we're lazy in a good way, right? Lazy in a good way, of course. So what do you notice here that before we plug in the values for these variables, what can we do to make our lives easier here? Yes.
Distributive property.
Even easier than that.
Make the a to 0, 1.
Yeah, instead of a to the 0, let's just write 1. Because it doesn't matter what a is, a to the 0 is always going to be 1. Okay, so now we can plug in, we have fewer things to plug in. Negative 4, negative 3, times 4, minus 1, okay. Yes, everybody see how that's how it plugs in. Then inside the parentheses we do multiplication, we get negative 12 minus 1. Negative 4 here. Negative 12 minus 1 is negative 13. Negative 4 times negative 13 is? Anybody?
52.
Yes, positive 52. Negative times negative gives us positive. And there's 28. Make your life easier. You could have also, if you wanted to, apply the distributive property to this. So you would have multiplied each of these things by negative c. So you would have had negative ac squared minus, plus c. You could have written it like that, right? Because negative 1 times negative c gives us positive 1c. You could have done that and then plugged it in, and we would have gotten negative 3 times 4 squared plus 4. Okay, first we do the exponent, then we do the multiplication. Negative 3 times 16 is positive 48 plus 4 is 52. So you could have done that also. But this is something you can do. Give it to me.
I never had any. I never had any.
This is something that you are allowed to do. Before you plug in the values for this, you can put it into a more convenient format, if you like. All right, next.
19.
Yeah, I know you've got some to ask. Okay, 19. 19 is, the only thing that is difficult about 19 is that it involves fractions, which are annoying. Luckily, they aren't decimals, which we hate, but they're still annoying. 3 1/3 x minus 1/2 equals 5. Okay, forget about the fact that these are fractions. The fact that they're fractions only makes it difficult because arithmetic of fractions is a bit more involved. In terms of the algebra here, it's very straightforward. So what do we do first? We've got 3.5 x minus 1/2 equals 5. What do we do?
Turn it into improper fraction.
Before we do that,
Make 5 a fraction.
No,
Nope.
add 1/2 to those.
yeah, we can get rid of this 1/2.
Oh, yes, isolate the variable.
Right, so we need to move the constants over to one side and the variables to the other side. So right now, all our variables are already on one side. So we need to move the constants onto the other side. We've got negative 1/2 over here and 5 over here, so we need to move them to the same side. So we add 1/2 to both sides, cancels it out on the left, and then we're going to get 3 1/3 x equals 5.5. Yes?
Yeah.
Okay, now what are we going to do to get this variable by itself?
Divide by 3 and 1/3.
So we get x is equal to 5 1/2 divided by 3 1/3. How do I divide two mixed numbers?
Now we must multiply.
Well, just
Oh,
divide
you
the
changed it.
reciprocal.
Or, well, no, we
Okay, but- Yeah, we're going to have to change them to improper fractions first. So what's 5.5 as an improper fraction?
11.
Yeah.
11 over 2, and 3 1/3 is an improper fraction?
10 over 3.
10 over 3. Okay, and then we do our rule, which is what?
Okay, thanks.
For dividing fractions, keep change flip. So we've got 11 over 2 times 3 over 10.
Equals 33 over 100.
Yeah, and we can't simplify this at all.
Wow.
We just multiply across the top, get 33, across the bottom, we get 20. Okay, the only thing that's difficult about that is that you have to work with fractions and mixed numbers. No, the end of class. We don't need it now.
Yeah, it makes me keep my light warm.
All right, next. We can do 2 more or so for this problem set. 23. Okay, so here in 23, with these problems, these are not I think these problems are poorly phrased. When they ask a question like this, it's not a yes or no question. It means which one of these two is a root of the equation. What's another word for the root of an equation?
What is x equal?
Yes, or solution of the equation.
Oh,
So we've got x squared plus 5x
that's really awesome.
equals negative 4. Yeah, so and then we can plug them both in, and we find that what is it, negative 1?
Yeah.
Yeah, negative 1, right? Because then we try it out with both of them. Negative 1 squared plus 5 times negative 1 equals negative 4. Okay, negative 1 squared is 1. 5 times negative 1 is negative 5. Negative 4. Okay, so we end up with negative 4 equals negative 4. Hey, that's true. By plugging in negative 1 for x, we made something true. What would happen if we did it with 4? Well, we have 4 squared plus 5 times 4 equals negative 4. All right, let's see. So 16 plus 20 equals negative 4. 36 equals negative 4? No, it doesn't. If you end up with something like that, I can't tell you how many times I've seen this on tests where somebody gets the end of a problem and they write like 36 equals negative 4, and that's the end. Yes, it doesn't make any sense. You're right. So if you get something that doesn't, negative 4 does not work there. Negative 1 does work. So it's a root or a solution of that. To which one?
The one that you do.
Negative 1. Right, negative, if we plug in negative 1,
I don't know how I got that. All my root is never negative 1 on my paper.
well,
Yeah.
that's why we ask you to write out your work.
I mean,
Now,
I got it. No, I know.
maybe you did it in your head.
Yeah. Oh, if it's one of those, I do look at my.
Yeah, so with these ones, it's a bit easier because they narrow it down for you to 2 possibilities.
I only needed to
Yeah.
do one of
For this
the
question,
one
can't
of
we
the
just say
things.
No, because they're asking you which one. It's a poorly worded question. What they mean is which one is a root of the equation,
Yeah.
not is it the case that one of these is a root.
Yeah, it's really easy. All you have to do is look at the end number and then you can just like figure it out. Cause like if I think the other number was like negative 4 or something, right?
4.
Yeah, it was 4. I'm like that doesn't make any sense. Cause if you times 4 times 5, that would be definitely 20.
Yeah, and so unless the first thing is negative 24, which 4 squared is definitely not negative 24. Yeah. Okay, with these ones you can just try plugging it in. Okay, next up. Time for one more.
Number 25.
25. Okay, yes. 25, we're using the distributive property. And here's what they give us. P to the 0, x to the negative 1, parenthesis, x minus 2x to the 0. Before we do anything else, what should we do?
We should use the distributive property making one.
No, before we do anything else.
Maybe to the 0, 1, x to 0, 1.
Right. We should make our lives easier. P to the 0 is 1. So we can just write x to the negative 1 because that already means 1 times x to the negative 1. If I don't have a coefficient in front of there, it just means one of them. Okay, and then in here we've got x minus, what's a simple way to write 2x to the 0? 2, because x to the 0 is 1, and 2 times 1 is 2. Now we can distribute. What do we get when we distribute x to the negative 1 into x?
1.
Negative or 0.
0. So
You get
Is
1.
it, what do we get, 0 or 1?
you get 0, but it turns into 1. Right?
What?
Oh,
X to the negative
we're
1
gonna
times
negative
x.
1.
It'll equal x to 0. So it'll
Right. So remember x, if there's no exponent, the exponent is 1. X means x to the first. When we multiply two things together that have the same base, we add the exponents. So x to the negative 1 times x to the 1, we add the exponents. Negative 1 plus 1 gives us 0. So x, but the answer is not, the result is not 0, the result is x to the 0. And what's x to the 0 equal to?
One.
1. Okay, so that becomes 1. What about x to the negative 1 times negative 2?
2.
Yes,
2x.
Negative 2
Oh,
x to
yeah.
the negative 1. Negative 2x to the negative 1.
Yes.
This negative is a different kind of thing from this negative. The negatives in the exponent mean something different. There you go. 1 minus 2x to the negative 1. Okay. Let's look at page 131, word problems. So back in lesson 30, we talked about using words to describe algebraic expressions and translating from those words into mathematical symbols. Here in 32, we're going to expand that, and now we're going to have those, where what you're going to need to do is to take the words that are there and solve it by first converting the words into mathematical symbols, and then you'll be able to treat it like any other algebraic equation. So remember that is means equals to, of means times, twice means 2 times, opposite is negative, all that stuff. Okay, so we have here, in the first example, the sum of twice the number and 13 is 75. So the sum of twice the number and 13 is 75. Somebody tell me what I need to write here in order to translate this into math symbols.
N plus 13. Wait. Oh shoot.
It's right there on page 131, example 32.1. You can start wherever you like here. Somebody translate some word there into mathematical symbols for me.
2n
Okay, twice the number, that's 2n. Great.
plus 13.
Right, because we have this, we have the sum.
Are you looking for your gun?
Sum means addition.
Looking for your gun?
Sum means addition, and what are the two things that we're adding? The sum of what? Twice the number and 13. Okay, the sum of twice the number and 13 is 75. What else do I have to write? Equals 75. Does everybody see how I got that from the words on the page? The sum of twice the number and 13 is 75. At this point, we can just solve it like any other equation. We subtract 13 from both sides. We get 2n is equal to what?
62.
62, so n is equal to
31.
31. There's your answer. Next example. Let's do a more complicated one. On page 132, example 32.3. 32.3. Find a number such that if 5 times the number is decreased by 14, the result is twice the opposite of the number. This one's a lot more complicated. Find a number, a mystery number, such that if 5 times the number is decreased by 14, the result is twice the opposite of the number. Where do we want to start here, translating this into symbols?
5 times n.
5n.
Okay, 5n, right? 5 times the number 5n,
Minus 14
right? 5 times the number is decreased by 14, great, minus 14.
equals 2 negative n.
2 times negative n, right? Twice the opposite of the number. 5 times the number decreased by 14, the result is, just means equals, twice the opposite of the number. Or we could write it like this, 5n minus 14 equals negative 2n. Then we just solve it like any other. So we move the variables to one side, the constants to the other. So to move the variables on the left, we add 2n. We add 14. Okay, we get 7n equals 14. N is equal to 2. All right. Let's do,
We're done.
30.
Number 33, we did it.
let's just do the last one, 32.5. Okay, we get the same result if we multiply a number by 3, or if we multiply the number by 5 and then add 2. we get the same result if we multiply a number by 3, or if we multiply the number by 5 and then add 2.
N times 3.
Yeah.
Uh,
So if we multiply a number by 3, we get the same result as what? 5n plus 2. We get the same result equals, these two have the same result. Multiplying a number by 3, or if we multiply the number by 5 and then add 2. And then same deal where we're going to move our variables to the same side by subtracting 5n. Constants are already on the same side. Negative 2n equals 2. So n equals what? Negative 1. All right. Questions about these? Please be careful with these, because if you mess up translating it into algebraic equations, you're going to have a hard time. Okay. In math, we have lots of numbers. Surprise, surprise. There are lots of different ways that we can talk about numbers. What are some different types of numbers we've had so far?
Integers.
We've had integers. What's an integer? Not necessarily.
I think it's like 8.
Be a little more specific. An integer is a whole number. What else can we say about it? Because we also have something different called whole numbers. What are natural numbers? First of all, natural numbers are counting numbers. What are those? You should all know this. Everybody should be eager to answer this.
2, 3, 4, easy.
Right, 1, 2, 3, 4, etc. They're all positive. They don't have any fractions or decimals. They go on forever in the positive direction. Okay, what about whole numbers?
0, 1.
Right, whole numbers are the same thing, but they start with 0. 0, 1, 2, 3, 4, 5, etc. Integers are, if we take the whole numbers, but we also include negative numbers. So 0 is an integer, 1, 2, 3, 4, 5, etc. are integers, negative 1, negative 2, negative 3, etc. are integers. Yeah, but remember you need dots on both directions for integers, because they go infinitely in the positive and in the negative direction. Okay, so that's integers. What about rational numbers? What are rational numbers?
Like decimal.
Decimals and
Fraction.
fractions. Anything that we can write as a fraction is a rational number. Another word for a fraction is a ratio. If we can write it as a ratio, it's a rational number. Decimals are fractions. They're just all over powers of 10, right? 0.5 means 5 over 10. 0.73 is 73 over 100. Yeah. 73 over 100 is 0.73. Okay. Those are rational numbers. All right, we also had real numbers, which include things like pi, which is not a rational number. There are also imaginary numbers, which we're not worrying about for this class. Numbers like I. We can think about numbers in some different ways also. And here we have the distinction between prime numbers and composite numbers. When you talk about prime and composite numbers, we're always going to be talking about integers. Prime and composite.
Aren't they like a number you can multiply to get a
To get what?
to get an answer? So like if it's 12, it'll be 1, 12, 3, and 4, 2, and 6.
Aren't they numbers that you can divide them?
So prime numbers can only be divided by themselves and 1. Prime numbers can only be divided by themselves and 1. Any number we can always divide by 1 and get an integer. Right? Obviously, we can divide anything by any other number, but we'll end up with a fraction. And get an integer answer. So what are some prime numbers? 13 is prime.
7,
7 is prime.
9, no, you can divide.
Not 9, because 9 is divisible by,
11. Oh, sorry.
right, 9 is divisible by 3. 11 is prime. 3 is prime.
17.
17. 1 is not considered prime.
31.
107.
31.
31 is prime.
33.
33 is divisible by 3 and 11.
41.
41, I believe, is prime. And so we go 2, 3, 5,
51.
7.
51.
51 is 3 and 17.
Okay.
Yeah. So
No, isn't 3 and 7? No, yeah, you're right. Wait,
Yeah.
what's 50?
you can also tell that 51 is not prime because we add the digits together to get 6. And remember, you add the digits together and you can divide that by 3. You can divide the whole thing by 3. So prime numbers are ones that you can only divide by itself in 1. So 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, etc.
You don't have to remember all of them.
What was that?
Or you don't have to remember.
No, it's a good idea though to be familiar with all the prime numbers up to 100. Yeah, so let's actually, okay, first of all, the composite numbers are
4, 6, 8, 9,
all, hold on,
12,
all other integers.
15,
All other integers are composite numbers.
18, 20.
The other way we can think of composite numbers is the products of prime numbers. A composite number is a number that we can get by multiplying two other prime numbers to get to. So 33, for example, is a composite number because we can get to 33 by multiplying together 3, which is prime, and 11, which is prime. Any number that isn't prime, by definition, we can get to by multiplying two prime numbers together. Yes? Okay. Let's see. Do we want to do this? This is a fun thing. I'll push off. I'll give you guys an option. We could do a sort of interesting thing about prime numbers that's going to take most of the rest of the period, but I'll push off the homework due date until Tuesday, or we could not.
Yes, let's do that. Does anyone want
Preferences? Anybody have a strong?
not that bad, but like.
Anybody have a strong preference to do this?
Yes.
Raise your hand so I can see. Anyone have a strong preference against doing this?
I don't know, because if you can do homework now, we also won't have homework over the weekend.
Exactly.
Okay. But.
All right, here, let's make a compromise because I think this is worth doing. So what I'll do is I'll tell you guys what the homework is, and if you really don't want to do this, you can start working on the homework now. But I think that this is really valuable to do to understand prime numbers and composite numbers and how they work. No, I don't give tests on Mondays.
When is our test?
Probably Tuesday or Wednesday. Let's see. Let's decide now. Test Wednesday.
Yes.
All right. Test. Well, that'll be test 7. Test 7. Wednesday. Wednesday. That's how I always say it in my head when I write it. So it's the same thing. Problems to 33 is all except 3 and 4. I'll give you the sheets, and then we'll do this thing called the Sieve of Eratosthenes.
What?
Isn't that a cool name? What? What are you talking about, Mr. Rowe?
Sick.
Oh, the definition? Yeah.
You know,
I guess.
you know, he wants to come to try hard.
All right, so you gotta give me a minute to write things on the board for us to be able to do this.
Here you go.
You said 50 through 50, right?
Let's see. A little bit higher.
No, my cover break.
Alright, just choose the test. I can't hear you.
It's on the
That's literally that.
There's some I don't have, but like, it's on like, number like 30 something or 20 something.
We're not all of them, but all of them.
Oh.
Oh, I can do it.
I freaking
Ask me, I feel like that's a logic.
Yo.
Yeah, but you like, yeah.
It has to be.
Is a product of negative number.
Fourth grade reading my mind.
It's a very good. Shoot from the start. Wait, 3, wait, why is 4?
Here, I'll show them all.
I'm just.
Here you go. That's actually smart, it's actually cool. But no,
Oh, it is.
low key, like, that's like, why is he so sweaty?
Oh, that's good.
He's so sweaty.
93 is not farmers. Wait, no, you're not writing down farmers. You're writing down time state.
Very good.
Huh?
Good.
It's like a double.
Oh god, I'm gonna fall.
Bro, if you have a, if you have a negative number, 1, 3, 5, 7, for the negative, it's
So we're doing problems at 33.
Por favor, may use the rest of them, please.
Don't you want to do the Civ of Eratosthenes? Is
Um,
it gonna be quick?
yeah.
Go ahead.
Bro, I'm looking at another.
You're still writing stuff down. So.
Yeah, that's what
I
I
will.
said. It'll be quick.
Wait, which one do we have to do for number 3?
3 and 4.
Why? Actually, no, I'm making a decision. I'm not doing 3, 4, but I'm also not gonna do 15, 16, and 17.
Why?
I don't know.
Okay, well, I'll make a decision not to give you full credit.
Because you're skipping. Problems at 33.
Is that every number? Did you just write 100 numbers?
Not yet.
Oh my goodness.
I'm committed to this.
Huh?
I will never do this.
We're gonna get the lower end.
Woo! Alright, sweet.
So,
Alright,
to 100.
so this is called, what we're about to do is called the Civ
I wanna erase it when you leave. Just leave it up there.
of Eratosthenes. So, a Civ, what's a Civ?
I don't know. It's like, I've heard of it before.
Civ, anyone?
A shit?
Civ. S-I-E-V-E.
Isn't that when you stab somebody?
A sieve is like a colander. You know what colander is?
Mm-hmm.
Like you're making noodles and you pour them into that thing that has all the holes in it
Yeah.
so the water flows out but the noodles stay.
Yes.
Okay, that's what a sieve is like. A sieve usually is finer. It's used for separating out like little particles of water. Okay, and Eratosthenes was a Greek, an ancient Greek who he was a mathematician, a scientist, all this stuff. He did some amazing things like calculating the circumference of the Earth in the ancient world, because yes, people knew that the world was round since like 2,500 or more years ago.
No, dude, they call it flat. They're like Kyrie.
All right, so Eratosthenes developed this method for finding prime numbers by using a sieve, by sorting them out. And so, like if you're trying to get gold out of silt, little particles of gold, one of the things you'll do is, anyway, a complicated explanation. All right, so what we're going to do is we're going to eliminate numbers that we know are not prime. That's how we're going to find the prime numbers, by eliminating the ones that are not prime. So 1, we've already said 1 doesn't count as a prime number. Is 2 prime? Is 2 prime? Anyone?
No,
What can you divide 2 by besides 1 in itself?
nothing.
Okay, so then it's prime. All right, now what we do is every time we find a prime number, we go through and we cross out all the numbers, other numbers that can be divided by that number.
And then we're gonna do what? We're gonna rewrite it?
No, I'm just going to cross them out. So what can we divide by 2?
4, 6, 12, 10,
Wait, you skipped a bunch.
8,
8, 10, 12, 14, 16, 18, 20, 22. These entire columns here of even numbers, they're all not prime. Even numbers, a number being even means it's divisible by
2.
2. So how can an even number other than 2 be prime? It can't. All right. All right, so we already eliminated a whole bunch of numbers that we know are not prime. We go to our next number. 3 is 3 prime? Right, it is prime. We can't divide it by anything other than itself and 1. What numbers are still here that we can divide by 3? 9. Okay, so 6 already out. 9. 12's already out. What else?
5.
18.
18's already crossed out. You skipped 1. What else can we divide by 3? After 12 comes.
14.
What's 3 times 5?
15.
15, thank you. Okay, 18. What's next? Come on, feed them to me.
21. I got 3. 2.
Keep going.
38.
No.
15.
What else?
Equals 2 correct.
It's
Come on, just 3 times tables. After 21 comes what?
That's 28.
No.
3 is 7.
Just add 3. Just add 3. Okay,
4.
already crossed out. Next.
30 is 7.
Keep going.
32.
We've got a lot of numbers to get through. Go quickly, please.
32. Wait. Sorry. I did a smooth brain. Okay, chill. 30.
Just say the numbers. Hurry up. We're running out of time. So, 27. What's the next multiple of 3 after 27? Just keep adding 3. Geniuses.
30.
Keep going.
33. 36.
Going. You just have to add 3 each time.
39. 42. 45. 48. 48, yeah.
We don't know how to write the products of the.
51. 54. 57. 60. 63, 66, 69. Nice. 70. 72. 72. 4.
1, 2, 3.
Yeah.
We're just counting by 3s, guys. After 72 comes.
75. 78.
81.
Yeah.
84.
87. Yeah, 87.
90. 93. 96. 99.
Okay. 4's already been crossed out. We know it's not prime. What about 5? Is 5 prime?
Yes.
All right. Let's eliminate all the multiples of 5 that haven't already been eliminated. Now, the way I set this chart up, it's easy.
10, 15, 20, 25.
Yeah, so all the 10s have already been crossed out. So it's just the 5s. 5, 15. So 15, 25, 35, 55, 65, 85, 95. Great. What about 7? Is 7 prime?
77.
Is 7 prime?
Yes.
Yes. Okay, so what multiples of 7 have not yet been crossed out? Let's see. After 7 comes what?
14.
Then?
21.
Then?
28.
Then?
35.
Then?
42.
Then?
49.
Ah. What's next?
54.
Okay.
56. Yeah, that's all that's
70, 63.
63.
72.
That's 70.
70.
Then?
77.
Then?
84.
Okay, then? Just add 7. 84 plus 7 is?
91.
91. Okay. All right.
Well, I've never actually done it 7 times. Wait, what time's
I've
7 times?
never done that.
That's like 13.
13, yep. Okay, so 8, 9, 10 eliminated. 11 is 11 prime?
Yes.
Okay, what multiples of 11 are still around? They're actually all gone already. 22, 33, 44, 55, 66, 77, 88, 99 are already all out.
I have a question.
Yep.
How do we do the product of a prime practice?
Well, we're getting there. We got to talk about prime numbers.
Yeah, man, let the man see.
You know, I forgot about getting to that part. That's why I'm pushing it off to Tuesday.
Oh.
All right, we'll have this be due Tuesday. We'll talk more about 33 on Wednesday. But I do want to finish doing this sieve here. All right, 13 is 13 prime.
Yeah.
It should be. We haven't eliminated it yet. Okay. What's the next multiple of 13?
26.
Okay, already out. What's next?
39.
All right, already out. What's next?
Not number.
Come on,
I don't know.
at 13.
50 something.
What's 39 plus 3?
That's 42.
Plus 10 is?
52.
Okay.
I said 50.
It's just already out. What's next?
Wait, I got this. 65.
Already out. What's next?
I think they're all out. 78.
Already out. What's next?
80. No. 83. No, 91.
91. Already out. Okay. 40, 50, 60 are out. 17. What's 17 times 2? Okay. Then 34 is already out. What comes next? 51 is already out.
Thank you.
What's after that? Come on. This shouldn't be difficult. After that,
Big boy numbers.
50. Come on. It's really you gotta get to the point where you can do this in your head. 51 plus 17.
Well, I can't just take
68.
68. Okay, that's already out. What's next? It's 85. That's already out. After that is over 100. So we're gonna skip that. 19 is prime. What's 19 times 2?
36. No.
38.
Yeah.
Okay, but that's already out. What comes after that? 57,
Maybe.
which is also out. Then comes 76, which is out. Then comes 95, which is out. Okay, 23, 46 we've already eliminated. And what about 69's already been eliminated. And then after 69 is going to be 72, which is already eliminated. All right, 29. 29 times 2 will already have been eliminated. 29 times 3 is 87, which is already eliminated. Okay, 31. 62 is already out. 93 is already out. 37. Okay, 74 is already out. And 3 times that is too much. Okay, the rest of these are our prime numbers because 41 times 2, any of them times 2 is not going to be is already eliminated because we eliminated all multiple 2. So these remaining numbers are your prime numbers up to 100. You don't need to memorize them, but you should get to the point where you're familiar with them, where you see one of these numbers and it sort of rings a bell in your head. Maybe this one's a prime. Those are your prime numbers up to 100. Especially the ones up to like 47 or so. You should be familiar. You should try to be familiar with. And I mean the ones, certainly the ones up to 29. There's no reason you shouldn't be familiar with those.
Wow.
Because there's just not that
There's
many
the
of them.
band numbers.
And the van numbers, right? The vans are 2, 3, 5, 7, 11, 13, 17, 19, and 23.
That's sad.
The school bands.
The only way I know prime numbers is the band.
That's an advantage of numbering them that way.
Oh,
Because
All right. Bye.
we have Mr. Victor, so he's a weird math.